Welcome back, everyone. This is video 3 of 4 on performing operations on real numbers. In the last video, we took a look at how to add, subtract, multiply, and divide real numbers, as well as apply exponents to them. So please be sure to take a look at that video first if you haven't already. It's going to be very important for this one, because in this video, we're going to be talking about the order of all of those operations that we're supposed to use on expressions that involve multiples of them. Let's get started. Please excuse my dear Aunt Sally, or PEMDAS. That's the mnemonic device that I learned to help me memorize the order of operations when I was in school. PEMDAS is an acronym that stands for parentheses, exponents, multiplication, division, addition, then subtraction. And this is the order in which we should carry out our operations on real numbers when multiple of them appear in a given expression, like the example I have here on the right. Here, we have lots of those different kinds of operations showing up all over the place. Let's get started on learning how do we use order of operations. The first thing I need to look for are parentheses, and I've got lots of them floating around. So how do I pick? Well, we always start from our innermost set of parentheses, but maybe even that's a little bit confusing because of the fraction bar in this problem. So it might be more helpful to write this as numerator divided by denominator. Now, it's a little bit easier to see that these parentheses are my innermost ones. But there's nothing inside those ones that I need to simplify. So we'll move out a set of parentheses. And now I'm looking here. Inside these parentheses, I'm now going to run through PEMDAS. And the next thing I need to look at are exponents. I do have one exponent to take care of, so I'm going to do that now. 3 squared, I know, is 9. And I'm going to leave the whole rest of the expression alone. Now, again, looking just inside this set of parentheses, I don't see any more multiplication. I don't see any division or addition, but I do have subtraction. I have 9 minus -2. Remember, to subtract a negative, this is sort of like adding. Right? One big plus sign there. So I'm going to add 9 and 2 to get 11 squared. And this resolves that bottom set of parentheses. Now I've got some parentheses on the left side I need to work on, as well as the right side, right? These are both kind of at the same level, so I can do these at the same time. Inside my left set of parentheses, I see an exponent, so I'm going to take care of that. And I get 9 again. And in my right set of parentheses, I also have an exponent. 11 squared is 121. And just as a tip, I would recommend that you learn your perfect squares up through 15 squared or 225. Not that it'll be necessary for you to be successful in this class, but it will help quite a bit, just as far as making things go a little faster. Okay, but getting back to the problem. Now, I still have a set of parentheses I'm looking at. The next thing I need to look at are multiplications, of which I have one. 5 times 2 is 10. Minus 9. Divided by 121. The last thing inside those parentheses is the subtraction. And 10 minus 9 is 1. Divided by 121. So my final answer is 1 over 121. Let's take a look at another example. Why don't you pause the video here to see if you can try this one on your own? 1,535. Kind of an ugly answer. The first thing I did was rewrite this fraction as division so that my order of operations were more clear. The trick to this problem was those absolute value bars, but they work just like parentheses. So I resolve everything in those inner set of parentheses first. I did my exponents, then my addition, and then I applied the absolute value, and that resolves my innermost set of parentheses. Then, since I only had one set of parentheses on the left and right hand side, I could work on them simultaneously. I did my exponents, and then my multiplication, and then my division, addition, and subtraction to lead me all the way down to this line here, 12 over 195 divided by negative 26. Remember, to divide by a fraction, we multiply by its reciprocal. And I have an imaginary denominator of 1. So I flip that over to get 1 over 26, and then I get negative 12 over 50/70. That happens to have a factor of 2 that I can cancel top and bottom, which leaves me with negative 6 over 25/35. From this video, you should be taking away what order to perform operations in when multiple of them appear in the same expression. In the next video, we're going to talk about some really nice properties of operations on real numbers that can make our lives a little bit easier. So I'll catch you all in the next one.